All right, guys. So several of you have asked for a video with multiple files going on, so I picked polynomials. It's one we're working on actively right now. Plus, it has dependent files because we don't directly interfere with monomial, but we need monomial in order to properly use polynomials. So it's even more an extra layer of abstraction so you can see how things work. Okay, so polynomial is pretty straightforward. It's a multidimensional term. This is technically trinomials in every case, at least in the sample problems. Okay, so let's see. All right, here we go. Okay, so first thing we're going to do, monomial. Private variables, coefficient, and so forth. So here we go. Monomial. Okay. Public class monomial. Okay, here's our PIVs. Probably won't be able to stay this large zoomed in, but we'll go from there. Okay. And then let's check. Okay. Methods. Create accessor methods for each private instance variable. We'll do that in a second. Monomial. Okay. Constructor initialize. Okay, so I remember correctly. Okay. Okay, so monomial, very short, very sweet. That's all we need. It just returns those values so we have direct access. We need these because of the private case. If they were public, we could access them directly. But again, going by AP standards from what we're learning so far, these should always be private. So we need to have getter methods installed. All right, there's monomial. So this whole thing is done. Polynomials long. Okay, so polynomial. So these have monomial values as their private instance values. So I'm shifting over here. Okay, so yeah, so this one has multiple constructors, which is part of the issue going on. So let's take a look. Again, we'll make accessor methods in a minute. Okay, so the default constructor is when there's no parameters, and then it returns everything to null. That's pretty straightforward. This one just directly applied. So, okay, we can write those two. It's empty. Okay. And this one's going to be the same thing. And this time, use the variables. Okay, evaluates the polynomial for the given value of x, plug in repeatedly using both coefficients and exponents to do so. Okay, so this one's probably going to be the more complex of them. All right, now we know, because we can look at the problems that they're giving us, that everything is a trinomial. But on the off chance they're not, we need to code it as if it's not. It could be any variables, it could be any exponents. They don't always have to be 2, 1, 0. So we're going to code it as if they could technically be anything else. All right, so this is the value we're plugging in, and then we have access to all these terms up here. Yay. Okay, so double answer. We could do it all in one, but I liked what I saw some people do where they split them up just to make it a little bit easier to deal with. Okay, so first term dot get coefficients, 2's I believe, times math.pow x, and then first term dot get exponent. Oops, needed a capital. Semicolon. Okay, and then we just update this twice more for the other two terms. So 2 becomes second. And this becomes third. There you go. Okay, so we've raised x to whatever the exponent is for each term. We put those together. You could combine these two in a single term, not even have a variable. That's fine. This just simplicity, just because it's the same code over and over again, easy to follow and monitor. Okay. Okay, return a string representation of this polynomial in the format below. You may assume each term will be non-null. Also, don't worry about signs like negatives in front of pluses. Okay, that's fine. Okay. So they want it in this format. So here we will assume. So based on the format that they want us to get to, they don't want us to include the 1 or the 0 or something like that. So we will assume that they are there. There was no pre-checks in here that were identified that would be the case, but again, we're taking this as the literal that it's written, so we're going to go with that. So we basically just need to print out that format. So square x by itself and then nothing. Okay, so toString. Now here's where, I think I mentioned this in the other video. You do need an override, okay? ToString exists every time you make a class. It's one of those automatic things Java does. You will get a little warning here. Based on what I've seen, they may have pushed out an update to the Java that we're using, possibly up to Java 23 now, where it does just list a warning. Previously, in other years, you would have had to do it because it would have given you a red error and it wouldn't have run properly. So I think something may have got pushed out over the last summer. Okay, so we need to make a string, and then we're going to format that thing. So we're going to do these right here. I'm just going to steal these because I've already used them. And then I have x raised to. And while, yes, you could probably get away with just putting it 2 there, I am going to at least use their variables so that it looks appropriate. Okay. No, that's why. Here's where I need it. Okay, so now I concatenate a plus sign. And now I do the same thing here. But this time it's just an X. I don't have to worry about the 1. So that I don't even have to do that. So I can do that. Yay. And then I just need the third coefficient term. Now, this is probably the one that we're assuming the most on. It's a little messy. It would not fit if things are not purposely in this order. So one of the questions, I know we're going to have to be very specific about where we actually label everything. But that should still give us the basic idea. Return S. Okay. So there is polynomial. So we've got both of our helper methods ready, or helper classes. They're good to go. Now we need to run the full code. Oh, no, wait, I'm not done. I need to do the accessor methods. Back I go. Okay, so. Okay. Get. I don't know if we're going to actually use these in this particular one, but it did say to do them. So there. Very simple. Getter method's very straightforward. Reason why the return type is monomial is because that's our data type up here. Okay. All right, so those are good. I'm going to save them so I don't mess them up. Okay. All right, so here are our 3 problems at the bottom. Okay. So first one's very simple. We're just evaluating. I'm going to copy this so I don't have to flip back and forth. So number 1. Okay. So we know we have values. I'm going to code them. I guess I'll code them as simply as I can. So monomial A. Very creative. Okay, so new monomial. So my first term is 4.32. Second term, the exponent is 2. This one is negative 2.12 with a 1. And this one is just 3.67. Okay, there's my monomials. Polynomials. Okay, new. Let me just list A, B, C and send those over. There we go. Now, okay, so now we're ready to start printing and calculating. So f of 2 equals, and now p1 dot evaluate, and I send it a 2. Again, I'm getting this Java dot buffer. I'm not sure what's going on, but some students have told me this has happened as well. They're just sitting there and then it doesn't, just kind of freezes randomly. I do not know what's going on. See, it's updating again here. All right, so let's give this a shot. 16.71. That is exactly what we're looking for. So we're good there. All right, on to number 2. Suppose the concentration in parts per million of a new medicine in the bloodstream for T hours is given by the following equation. Okay, I'm going to copy that. Write code to print the table that shows the concentration for each of the 8 hours to ensure proper dosing. Okay. So I'll do my setup pretty much the same way I did that time. Print that out there. And I'm really just kind of going to do the same setup to get started. My monomials are easily recyclable, so I'm just going to get new ones right there. Okay, so I'll put those in because that's going to bug me later on if I look back at this and forget what I was doing. Okay, so this one is negative 0.05 with a 2. Then I just have a positive 2 in both of these. Okay, this would be polynomial 2. All right, and here's where it gets a little different. So I don't just want one evaluation. I want multiple evaluations at different time frames. So I need a loop. This is equal to 8, just be simple. I plus plus. So I is going to be my hours, or my T in this case. And so I need my evaluation value in the print statement. So, all right, so let's see. First thing I need is I need the hour. And in fact, I can even give myself a little bit of a header here to explain it. Hour. So that'll just be my I. And then I'll do /T to tab it over. And that's probably a good enough evaluation. And then I just replace the number with the variable. Okay, so let's give that a shot. So we need to put a spacer in there. Okay. Okay. Ooh, not the numbers I was expecting. Okay.
5 minutes later.
So much. Oh, because I did not replace these. Okay, so let's try this again. Okay, 14.8 works there. Good. Charts table is kind of up to you how to interpret it and give us a format. Some of y'all were forcing the rounding. I guess that's okay. It doesn't hurt anything, but even without any formatting, it came out pretty legible. All right, so last we get number 3. Okay. Okay. So this is similarly going to be, this is the one we have to edit the most. Okay. So I'm going to steal all this again. Okay. G, H, and I, 3, G, H, I. Okay, so here's where we have to rearrange it because this one is in the backwards format. Now, because of the format they gave us, we need to flip the order. Okay, so this is going to be coefficient first term. Okay, so negative half times G. It tells us to treat G as 9.8. You can do the math ahead of time. That's fine. Or you could do this. Java is smart enough to do math inside there, and that's going to be our square. Initial velocity, which they just said is 50 meters per second. And then the starting height is 3. Okay, good. So first thing I'm going to do is I'm going to set it up just like we did part 2 with a loop. Okay. No idea how far it's going to go, so let's do a while. While P3 dot E. No. How do I want to do this? No, I think that is it. Okay. P3 dot is greater than equal to 0. That way I know it's at least the projectile itself. Um, I need to give it T. This is a while. I need the variable up here. Okay, no, error went away. Okay, so this one's where I can probably do some rounding. Let's do something like this. Okay, so I want to know what time I'm at. And I want to know what the evaluation is at that time. And I believe it did say, yeah, increments of 0.1 seconds. So that's going to be right here. That's why T's a double this time instead of an integer. Okay, so let's just see what it's like airborne. Okay, goes through there. Definitely getting some feedback right there with the decimals. We can format this one. This one looks like formatting there, so it hit over 100 and it's come back down. So the whole thing is in the air for a little over 10 seconds. We can do that. Okay, so let's change this to a printf. Okay. Ooh. Let's make another one. Okay, so the first thing I need is going to be T for time. So percent decimal value is going to be F. I'm going to round it to 0.1 for the time. Then I can put the tab. Then I need the next value, which is the elevation. I don't need to concatenate it. It's all strings in this one. Never mind. Blanking on context. Okay, so again, let's say 3 is probably good. F and then /n for the line. Okay, there we go. Like that. Okay. Okay, let's check formatting. Okay, I don't need the plus sign. Take that out. So 0, it's above, it's below. Okay, so 10.2. So now. Okay, so now we need to limit it. Okay, so if P3 dot evaluate is greater than equal to 100, that's when we print. Job about uploading again. Come on. There we go. Okay, so starts at 2.7, ends at 7.5 or 6, I guess. Okay, must be too low at 7.6. That would work. It doesn't say what kind of value it wants. It just wants to know what times it is. Um, but we can do this a little bit better. Let's see. Okay. Play around with this a little bit. It's above 100. And then something like that. Don't need to print every single one now. Just need to find where it's greater than 100. Using that Boolean. So we know this print works. Just store it here in case I need it. Okay, so that's going to end that if. Okay. And as it's coming back down, and it's less than. T, and then I'll be done because I'll have both values. Okay. The rounding is going to be an issue. Let's just use this. First one will be high. And the same one will be low. So we know the values I'm looking for. This is just me trying to print it out in a particular way. Okay, so there's our heights and our values. This is all they're really asking for. They didn't even say put it in a sentence format. Times there you go. Something just to label it, just to let them know what's going on. Yeah. So this one, very, very many different ways you could do this one, especially the output itself. This is just checking to see. So the reason I'm using a Boolean is because we know it's a quadratic. It's going to go up and then down. So I did a little Boolean flag right here to let me know that it's gone above it the first time. So it keeps incrementing until it hits that. Then boom, there's the high point. Keeps going. That now checks the second if, and then as it comes down, it hits it a second time, and that's what we're looking for, those two values. Ways they could have adjusted this: how long is it in the air, that data subtraction element, what are the actual times. That would be using this print statement we did right here with the if test, because they'd want to know the actual times. Again, probably the weirdest worded of the questions, but the code itself is not that bad. You can see it here. Hope this helps. You need to get into the practice of using multiple files. You need to make sure that objects have their own files at all times. When you're writing methods, that's when you can keep it in one file some of the times. But just try not to rewrite the question. You're going to get into bad habits, and those habits could be what cost you points on the exam. Hope this helps.